Is everybody pumped up? All right, that's what I'm talking about. I know it's late in the day. Thanks to everyone for showing up and coming out to hear us talk about how the Texas Rangers use a unified data platform to drive world-class baseball analytics. My name is Oliver Dykstra. I'm a data engineer for the team. This is my third season.
I'm Michael Topol. I'm Assistant Director of R&D with the Rangers. It's also my third season with the team and 10th year in baseball.
Yeah. Do we have baseball fans in the house? Does everybody understand baseball more or less? Okay, all right. Well, we'll still break it down a little bit for anybody who's not as familiar with how some of this works. Basically what we'll go through is a little bit quick history of baseball statistics. We'll dive into modern big data baseball and the kind of metrics and things that we're collecting. And we'll talk about some of the obstacles, potential that we ran into, the fundamentals that we use in data engineering, some analytics, and what it looks like at the end of the day. So just a quick history of baseball statistics. It's been around for over 100 years. Oh, first, yeah, Raleigh Fingers. You know, statistics is baseball. He said all baseball is numbers. It's run by numbers, averages, percentages, and odds. You can forget about those baseballs and bats. It's all cerebral, right? Henry Chadwick started publishing box scores in newspapers, so collecting basic information about how many hits and runs people were getting. It was over 100 years later, or just under 100 years later, that they started publishing these box scores on the back of baseball cards and started pushing out this sort of this data into the public consciousness and things like that. I don't know about any of you, but even when I was a kid, you know, we were all memorizing these stats for different players and things like that. Bill James pushed these statistics further into the public consciousness. He's kind of a titan in the world of baseball statistics, and he published this baseball abstract which started ranking players based on some of these stats and things like that. RetroSheet is a great volunteer-driven organization that I like to point to as kind of the start of really open sourcing baseball statistics and things like that. They're an army of volunteers that goes through historical records and newspapers, does data quality checks and things like that, and have contributed a great deal to our understanding and the history of baseball statistics. Baseball Prospectus pushed it further, not just in the public consciousness, but into decision makers' hands. They created some of new statistics such as VORP and PECOTA and these kind of things, and put these statistics in the front office where people who were making the decisions started to really get awareness of these. And of course, we would be remiss not to mention Moneyball. Right across the bay, the A's use statistics to find inefficiencies and undervalued players in the game. And so the basic idea here is batting average was a main way that was used to value batters. Just basically, you know, how many times they hit the ball out of how many times they were up to bat and how many runs they got on that. But Billy Beane and the Moneyball folks, they found that getting runs and wins was more highly correlated to a different statistic called on-base percentage. And so this really started to change the way people thought about things, right? You found an inefficiency, a market inefficiency. They were able to find undervalued players and sign them onto the team for lower cost than would otherwise be done. And it disrupted the industry and pushed baseball statistics beyond the public consciousness and into kind of a realm of its own where even Moneyball is used in other industries as a correlation for data.
Yeah, that was the 2001, 2002 of the A's, so that was almost a quarter century ago of when Moneyball was. So a lot has happened since then. this is just like a high-level look at some of the big technology, at least advancements over that time, particularly the last 10 years when StatCast was first introduced. But really going back to 2006 is the origin of PitchFX, which was a camera-based system to track the pitches and give us metrics we're used to, like velocity and release points and break. Over the years, that's evolved with both camera systems and also radar systems like TrackMan, to beyond just tracking the pitch, to tracking batted balls, to tracking the players themselves as they move throughout the field, and also now beyond just like XY coordinates on a map, we have like full biomechanic, like kind of skeletal data tracking of players. Yeah, this is just a overview of like what the modern like TrackMan, or not TrackMan, a StatCast or Hawkeye system would look at like. It's a 12 camera system, very high, so it's tracking not just the ball, but players throughout a play at a high frame rate. So you're really just recreating the play as it happens in data. And those systems that we listed before are mostly run through the StatCast system, which is a kind of a collective data source for the entire league. All teams have access to it, but it's also over the last 10 years or so like sprung up an industry of vendors as well that have various ways of collecting data. And this is just like an example of various ones in a lot of fields. And yeah, it's not just limited to games that you see on TV for major leagues. It's minor league games that are having all this data collected. It's amateur games, it's international, whether in Korea, Mexico, Japan, all over the world. So it's truly becoming like you're able to see equivalent data from players from all over the world at all different levels. And now we're just gonna show a few videos, I think, that just kind of, for teams, it's a lot of it's to be able to analyze players, but it's also a big part of broadcast and entertainment. And so this is just an example of some of the stuff that they're collecting.
Corey Seager now. Seager with 26 home runs. Go with his .271 batting average. 3-2 pitch, and that ball's blasted. Where will it end up? It is gone! Wow! That was way the heck up there. Number 27 for Corey Seager.
So exit velocity, distance, pretty standard stuff at this point, but we love watching Corey Seager home runs, so we're going to show it anyways. Maybe less Stanton home runs, but I guess we'll still show it because that's what we got. Oh wait, no, this is actually, but yeah, beyond just the batted balls, this is, like I mentioned, tracking the trajectory of the ball in play and also the fielders. You can go beyond just like box score metrics to also newer metrics like catch probabilities and fielding. And then even newer still, based on like the biomechanics data, we are able to dissect swings and bat tracking even more so. So beyond just seeing like an exit velocity and how far a ball traveled, you can break down various aspects of what goes into any individual swing. And this is a clip from our Kinetrax data, which is also like now it's part of kind of folding in more with Hawkeye, but part of the biomechanic tracking. And you can see like how precise it is at tracking the joints of our, in this case, pitcher throughout the play. And it lets us at various levels, well, whether it's an analyst or a biomechanist or a coach, just see like various things working with the player on their mechanics and trying to help make them better.
Yeah, like our associate used to always say, when we were in Little League, they'd always say, open up your hips, get your shoulders up, and now we can see exactly how much they need to adjust those things.
Oh, one more. Yeah, and another cool one that StatCast provides for us now is weather data. We'll talk a bit about it more, but you can see here like kind of the granularity that it's tracked and measured, and then like in cases like this, you can see it's showing like the effect that the wind had specifically on this play, which without win would have been an out at the warning track likely, but became a home run.
So getting to where we are today and dealing with all of this big data was not a straight line, right? Far from it, in fact. I'd like to bring this up here. This is an example of one of our pipelines to create one of our primary data products in the before times. Maybe I'm exaggerating a little bit and didn't quite get to a full data swamp, but nonetheless, it was there were some obstacles and burdens just to bringing in new data with a system like this, especially once we got biomechanical data. It kind of overwhelmed this system. It was expensive and time-consuming to maintain. It kind of had this black box effect as well, right? When we went to coaches or players and they wanted to know how we came to a certain conclusion. Like, why do you want me to change my swing in this way? Like, why is your data telling us that? And sometimes we just, we couldn't tell them why we thought that. And so we recognized the need for a unified data platform to be able to ingest many different kinds of data from different sources and to streamline the process through which we transformed them, ran our analytics on them, and provided our conclusions and KPIs to our end users. We knew that we had a worldwide presence. We have people in our minor league teams throughout the states. We have a presence in the Dominican Republic. We have international scouts, traveling all over the place. And we wanted to make sure that they were still able to work cohesively and have the same ground truth, right? In that system I showed you before, not only was it kind of a tangled mess, but there was also some silos building up where we had people, doing machine learning models on the same thing and reaching different conclusions, which was confusing. So we wanted to centralize our data into this sort of hub and spoke model so that our data team could do their work and share their, have the same ground truth for all of our different sub-departments, whether it's our pro analytics who kind of gets a lot of the fame and glory, but we also have our sports science, international analytics, amateur analytics, advanced reporting, and player development. And always bearing in mind that our teams and our coaches, they weren't kind of blind consumers of data. They wanted to have a conversation about the data, but they also had a lot of their own requirements, and they were thirsty for it. Young players these days coming up in colleges, sometimes they're at these like high-level colleges. They have larger data teams than we have. And so they're immersed in this already, and we knew that we had to provide for them. With our previous system, it was really tough to bring in new data sources. This is another few examples of new data sources that the MLB provides us just within the last year or two. Things like batter stance and arm angles and release points. And along with Databricks, we wanted to be able to have something that played nice with other vendors and things like that. So happy to have some vendors here that plug and played really nice with Databricks. We orchestrate all of our work with Airflow on Astronomer. We partner with Monte Carlo for data quality. We're hosted on AWS, and we use Tableau for our front end stuff. So one of the main pillars of success that our general manager imbues upon us is to dominate the fundamentals, and so we try to bring that spirit and ethos into our data engineering as well. So just a few fundamentals that we use. Of course, the Unity catalog. This really helps us to keep all of our various data users provided with their individual access, and while at the same time keeping in compliance with HIPAA. We do deal with a lot of medical issues, things like that. Contracts are definitely required to stay secret. We've been told we're one of the heaviest users of federated querying. Through our various migrations, we do still have some on-prem services, and during our migrations, it was super helpful to be able to reach out and pull in some of these tables from our legacy warehouses so that we could migrate step at a time and not all at once. And of course, MLB is primarily with Google, so we need to reach out to BigQuery and GCS regularly as well. We use system tables quite heavily. We were really excited when Databricks started releasing these, especially when it comes to compute management. We built some really great dashboards. We use some great dashboards to monitor our compute usage. And we could break these down by node types or by users or jobs. And you can see here in April, we had a little spike in usage. And so between our SQL alerts and things and these dashboards, we're able to monitor and get on top of misusage as quick as possible. Because as anybody knows, compute can get expensive real fast. With Monte Carlo, we use them for data quality. They help us monitor our tables and things like that and create monitors. But by allowing them access to our system tables, they're able to provide us even deeper query optimization information, whether it's read or write or anything like that. And again, it's broken down by users. So if someone, I need a lot of different ways to watch our analysts and things like that and see if anything is getting a little too expensive or running too long or anything like that. And then by scheduling through Airflow on Astronomer, we're able to build out custom alerts so that we're able to keep an eye on everything throughout our entire data ecosystem. Whether it's failures or just we need to know kind of what ran the last day and what's succeeding and failing.
Okay, now I'll go into more on the analytics side. Like I said, been like a quarter century since Moneyball, so low-hanging fruit of identifying walks as undervalued does not really exist anymore. I suppose the oversimplified summary of the change would be, instead of necessarily identifying value, which is still important, a lot of it is about maximizing the value of those players that you already have and working with using data to make them better. A more modern book on that would be the MVP machine, which was, I think, about 5 years ago now at this point, but still kind of represents a lot of the modern approach. When asked what areas analytics influences in a baseball operations department, it's basically everything. It's whether it's talent acquisition from amateur draft through trades or free agents, or player development, or in-game strategies, working with coaches and players, just any area that they're seeking the information to help themselves get better as individuals and help the team win as a whole. So this is an example of a projection, publicly available projection from Fangraphs. Pretty much, it's generally, I would say, the most important product of an R&D team. Any team will have their own internal version of this. This is kind of just like a batting line, but you see you're trying to project it, have confidence in how a player will perform in the future. And as we go a little more depth in the analytics, you'll see that basically this type of data we're looking at looks less and less like batting lines and more like these new metrics that we're talking about and trying to project. This is one slide that we had from last year. We did more of a around the horn of all the various parts of baseball that analytics touches. For this year, I decided I'd just try to focus a little more on hitting specifically, which is a pretty important part of baseball. We talked about the launch angle revolution and how analysis of combination of exit velocities and launch angles, basically found this sweet spot of valuable combination with high expected outcomes. So basically, nerds decided that home runs were important and groundbreaking stuff. But even this, I mean, it is funny to laugh at, but if you look 10 years ago, it really was not something that was necessarily emphasized in player acquisition or player approaches. It's kind of reminds me of like three-pointers and saying that they're more in basketball and how they're more important, but it really wasn't until recently that teams actually started optimizing towards that. And this was like 5 years ago, so now, I mean, even saying just hit it hard and in the air is probably an oversimplification. You'll hear emphasis on getting it, hitting it pole side and in the air, things like that. So how do we break down trying to see these the valuable hitting approaches? Well, these are some of the new data sources that Oliver mentioned earlier. And before I go deeper, I should just acknowledge and give a shout out to StatCast again, because pretty much all teams have some, with R&D departments, will have internal versions of a lot of these metrics, and a lot of the raw data is shared through StatCast, but is considered proprietary, so we're not really supposed to share it. But StatCast itself does a great job of making their own models and metrics so that we're to share with the public through broadcast and also their website, Baseball Savant. So most of this is pulled from there. But you can imagine most teams having similar metrics as well. So yeah, on the left we have just stance data, like beyond just like the hitters like XY position, you see how they move their feet in a swing, where they're positioned. On the right, did we play that one already? Maybe hit that one. Yeah, just like the tracking of a swing throughout the entire swing, we're able to generate new metrics such as bat speed, attack angle, swing path. So when we're talking about trying to pull the ball in the air, this is a type of data that can help us see how batters that do that well actually get to that. And one other metric from that sort of bat tracking and swing data that's not shown on there would be like where the position of the ball is along the bat. So beyond just the sweet spot of launch angle and exit velocity, we can see actually like the sweet spot of the bat and if it's being making contact there. And yeah, and this additional data that we've kind of talked about, we're able to, like obviously home runs are good outcomes, but outcomes often can have a lot of randomness that might be outside the control of the hitter or the pitcher. So we try to incorporate all the data that we have into properly controlling for that. So on the left is an analysis that Savant did using their weather data to show how many home runs were gained or lost at various parks last season because of the wind. So frustrating years for the Royals and Cubs, I suppose, losing a lot of home runs. And then on the right, we can see like beyond just like the weather, so we can also see based on just like the dimensions of parks, which every park is pretty unique, can impact the outcome. So this is an example of a Yandy Diaz home run in Steinbrenner Field at Tampa this year that it counts as a home run, but in reality, according to this, it would have only been a home run in 1 out of the 30 major league parks. Pretty rare because I thought Steinbrenner and Yankee Stadium have the same dimensions, but it's possible, I guess, weather or something could have impacted as well. But yeah, park factors have been like an important statistical method for trying to adjust stats and better project performance for a while now, but now, and they've usually done like kind of more on a season stadium level, but this allows us to use the granularity of a specific play and see what factors are in or not in the control of the players. And yeah, I guess one more example from the last one I would just add that came to mind was Isaac Paredes who's currently on the Astros. If you think about he's a unique case because he has hit a lot of home runs, but he doesn't have like a lot of the elite exit velocity of a hitter that you would be typical for a guy that hits that many home runs, but what he is really good at is pulling the ball in the air. And now he's in Houston, which has very short left field, so he has been hitting a lot of home runs, and you can see that. But it maybe for him depends what part, because last year he might have struggled a little bit in Chicago with the, as you can see, the wind has a big effect. So that's the type of stuff that you're able to optimize for in terms of player acquisition and everything. And then as we're incorporating all this data beyond just outcomes, and we're getting down to the mechanics of a play, the weather of a play, everything, one big, I guess, transformation of these last few years is part of R&D departments is going, not just having to do like statistical models, but the incorporations of physics-based models into modeling outcomes. Here in Texas, and also my previous position, I've worked with people with physics backgrounds that are building models and just able to really break down the types of the events that are going on in the play. And I guess NASA is interested in it as well, because they have done some work on the aerodynamics of the ball and the trajectory. And now that I've mentioned sweet spots and home runs and physics, I'm legally obligated to mention torpedo bats, which I don't know if I have much to say. That I think when they had hit all those home runs that one game, it was maybe overblown that they had solved and ruined baseball. But bat fitting has been a part of the game for a while now, and being able to incorporate this data, physics models, bat tracking models, and customize stuff to individual hitters is a real thing, and they've seemed to have done a pretty good job with that. But that being said, I would not go out and buy a torpedo bat for your like 11-year-old probably. And then this is one more cool example of how hitters are able to better prepare for games. This is a traject system. Basically, it's a combination of this new it's a very fancy pitching machine that uses, takes in pitch level data such as release point, velocity, and break. And so we can feed in any pitcher. So you're about to, whatever pitcher you're gonna face the next day. And it will, on the right, it has this feedback mechanism that it will basically learn how to throw the pitches of a particular pitcher. And that overlaid with the video and the release point then creates a full recreation of the pitch so that hitters can prepare for whoever they're gonna face. It's pretty cool. We had a Databricks team out to our complex in Surprise during spring. I don't think there's video of the CRO, Ron, going up against a Mason Miller slider, but if that video exists, it was quite good. And then, this is one more AI analytics example from our organization, actually done by my predecessor, Alexander Booth, who's now here as an employee of Databricks. But he was able to build, in cooperation with Databricks, like a chat application that worked on EBIS, which is basically like a database of all contracts or players. So you could ask questions of what is certain players and what their contracts are, and it was able to comprehend that and feed it back to non-technical users without them having to necessarily query through an entire database and look for answers. So putting it all together, we've kind of shown how it goes together a lot. Another attendee here, our boss, Ryan Murray, a quote from him, "If you can make yourself 0.5% better, then that's a win. It can be the difference between making the playoffs and not making the playoffs." That's really like I said, it's not about identifying walks of variable anymore. It's really about finding 0.5% wins here and there. These are just some examples of reports, and all this data that we are collecting. Databricks has really truly allowed us to run processing and send it through our models, turn it into reports really quickly after games. So, because there's a game every day, so you want to, if they don't get the report from one game till after the next game, it's too late. So these systems allow us to turn it around and get it quickly to the decision makers, the coaches, the players, so they can see the information they need and get better and prepare for the next game.
This is just another example of some of the reports we get out. Jonah, we do matchup projections, so our catchers, in this case, Jonah Heim, you can see that on his wrist there. It's a map of batters and what their preferences and things like that are. So he can take a look at that, and then he communicates with his pitcher. They don't use signs anymore now. They have little. He has a pad on his knee that sends the pitch recommendation to the pitch comm in the pitcher's ear. And of course,
I told Oliver, yeah, we can keep this on one more year. We didn't win last year, but we'll keep the slides this year. But I think if we don't win again this year, we have to take it off. So that's a goal. I mean, there's a lot of teams that you need good preparation, you need players, you need a little luck. It's always going to be a lot of that. But our little small part as a data team to help all those players in that year was really rewarding and something that all the teams are always striving for.
More pictures. And Databricks has helped us all along the way. Compared to our previous systems, we're moving 4 times the data at the same cost as we were before. Our users are governed securely and unified through the governance model. And our data's democratized more than ever. People are collaborating, they're sharing, and of course, as we said, we won a World Series with it. Thanks so much for your time and coming out to listen to us. Looks like we did pretty good on time, so we have some time here for questions if anybody wants to do that.